First, today's question is going to be based on the idea of bridge line theorem. So, in a triangle, if you draw a line from the vertex to the opposite side, then the triangle is fragmented into two triangles, and the ratio of their areas will be in the ratio of their bases. The reason is the two triangles have a common height drawn from the vertex A, and only their bases are different. Now, the interesting note to this is if I choose any point on this bridge line and connect to it commonly from the other two vertices, then the other triangles so formed will also be having the same ratio with respect to the bases, meaning area of ABE divided by area of ACE will also have the same ratio BD by CD. We are going to extensively use this idea into the forthcoming problem. So we are told a triangle ABC is a point D here, point E, and point F. And each of these points are dividing those sides in the ratio 1:3. So let me call it 1x, 3x, 1y, 3y, 1z, and 3z. Now these lines are being joined. And there is a triangle formed in between. So this triangle exactly in between, like it's named like KLM. So the question is, if area of triangle ABC equal to 1, find area of KLM. So now to do this question, we shall try to understand the extensive use of ridgeline theorem. If we draw connection from B to M, K to C, and then A to L, then you can notice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 regions are there. So using our bridgeline theorem, if I start from here, if BKD's area, I'm going to assume it as A, and KDC area will be 3A. Is that clear? And CLE area, if I'm going to assume it as B, then this area will be 3B because of bridgeline theorem. If this area is C, this area should be 3C. Okay, and followed by the other set of areas. So I'm going to call this area as D, this area as E, this area as F, and this area as G. Now, by the idea of bridgeline theorem, which I told you, if you notice that in the triangle ABC, with respect to point M, okay, if you notice it with respect to point M, then the area to this side, that is AMB area to the other side, which is AMC, which is totally becoming AMB's area is 4C, and AMC area is like 4B plus F. So this will also share the same ratio of their bases, it will be 1/3. So similar to this, similarly, we can write for the other things. Now, if I'm going to consider with respect to point K, then the area 4A by 4C plus D will also be 1/3. Okay, if I'm going to consider with respect to point L, then I will be having 4B by 4A plus E is equal to 1/3. So since these fractions are all equal, so they are equivalent fractions, they're all equal to 1/3. In equivalent fractions, the idea is if you add their numerators and divided by the sum of the denominators, that will also be equal. So if I'm going to do that here, the numerator here is 4C, numerator here is 4A, Numerator here is 4b. On adding them, I get 4c plus 4a plus 4b. The whole divided by denominator we'll find 4b plus 4a plus 4c plus d plus e plus f. So this should also be equal to 1 by 3. So if I cross multiply, we get to see 8a plus 8b plus 8c becoming equal to d plus e plus f. So we got a relationship between the newly formed regions D, E, and F with respect to ABC. So we need to do it one more time to get to know the relationships. Okay. So I'm going to consider this. We are considered with respect to M, and we got this area region 4C by this. So if I now consider with respect to the entire bridge line for AD line, then we can notice the area comes like 4C plus A plus D whole divided by 4B plus F plus E plus G plus 3A. So they should also share the same ratio as 1 by 3. And this is about the area ratio of area of ABD to that of area of ACD. If we cross multiply this, we are going to get 12C plus 3A plus 3D is equal to 4B plus F plus E plus G plus 3A. So 3A on either side gets cancelled off. Or rather than just cross multiplying here, we will keep writing the ratios based on all of these bridge lines drawn and finally apply the same equivalence property, equivalent ratio property here. So we are done with respect to AD line. I'll then do it with respect to BE line and then CF line. So now with respect to BE line, if we do the same, I'm going to have 4A plus B plus C, the whole divided by 4C plus D plus G plus 3B equal to 1 by 3. With respect to CF line, if I do the same, I'm going to get 4B plus C plus F, the whole divided by 4A plus G plus E plus 3C plus D equal to 1 by 3. The same equivalent ratio idea, if I'm going to add the numerators to the sum of the denominators, I'm still going to get it as 1 by 3. So let's see that. I have 4. This was written for the line AD. For AD line, we had 4C plus D plus A. Okay. On the other side, we had 4B plus F plus G plus E plus 3. So let's coming to add the numerators. I have a D, F, along with that I have combinations. So meaning like I have 5A plus 5B plus 5C plus D plus E plus F, that will be in the numerator. So let's come to the denominator. I have a 3G, okay, and then I have a D, E, okay. Yes. As we add the denominators now, so we recognize we have 3G's in the denominator. Apart from that, we have pairwise 2D plus 2E plus 2F, and then along with them, we have totally 7C plus 7A plus 7B. Since we had already got some result regarding the same, that is the value of D plus E plus F is equal to 8A plus 8B plus 8C, we wish to substitute this back. Okay, so since we have seen D plus E plus F is 8A plus 8B plus 8C, I'm going to replace wherever I find D plus E plus F. When I do that, the replacement for this D plus E plus F, so numerator becomes 13A plus 13B plus 13C. In your denominator, we are having 3G plus 2 times D plus E plus F, which will become again 2 times of 8A plus 8B plus 8C, which is becoming 16A plus 16B plus 16C, along with this 7 times. So we'll have 23A plus 23B plus 23 equal to 1 by 3. Then we cross multiply. We have 39A plus 39B plus 39C is equal to 3G plus 23A plus 23B plus 23C. So after subtraction, we get 16A plus 16B plus 16C is equal to 3G. So we got every term related to G. So this helps us to find the value of G. So they are given to us in the question, the area of ABC. Okay. The area of ABC triangle was given to us. So which is basically A plus B plus C. I mean, the entire area was 4A plus 4B plus 4C plus D plus E plus F plus G equal to 1. The entire area was like this. So now we got an idea how to rewrite everything in terms of A plus B plus C. So that should help. So I'm going to rewrite D plus E plus F as 8A plus 8B plus 8C. That will become 4 plus 8, 12. And G will be equal to 16 by 3 times A plus B plus C. 16 by 3 times A plus B plus C. 4 times A plus B plus C plus 8 times A plus B plus C. It's adding up to 1. So 12 plus 24, 36, 36 plus 16, coming 52 by 3 times A plus B plus C equal to 1. So A plus B plus C value is like 3 by 52. If we know the value of A plus B plus C, that means we know the value of every particular area, or at least the middle one. The middle one is being 16 times of A plus B plus C. So G value is 16 by 3 times A plus B plus C. So when I substitute it here, so I get 16 by 3 times 3 by 52. 3 3 gets cancelled, 4 4s are 16 and 4 13s are 52. So the answer for that is 4 by 52. Hope you loved this mathematical question. See you in the next recording. Thank you.